Okay, class. So today we're going to start to talk about our next unit is called chemical reactions, but we kind of need to review different states of matter because that will go into reactions as a whole, because we will be talking about different types of matter, how they react with other types of matter. So we're going to review different states of matter and how states of matter can change physically. So at the beginning of the year, we started the first unit. It was called Matter and Changes. We talked about things like solids, liquids, gases, and we talked about physical and chemical changes. Like I would ask you on a test, if water melted, it was originally a solid and changed to a liquid, what kind of change occurred? And you would have answered that question. It was a physical change. So I'm going to go over and review different states today and talk about the names for changes between states of matter, and kind of we'll piece that together with a diagram that is kind of like a graph that you would see in math class, but explains how a substance goes from one state to another and the change it undergoes to get from, say, a solid to a gas. And we're going to break down each individual piece. So I have put this note packet on Classroom. If you open up to Classroom, it is, I'm just going to show you on Chem 3, Period 2. It should be under classwork. So I put a little phase changes. It should be the first one on, and it'll say notes for a mini lesson on phase changes. You can just type in your notes if you want to right here. I'm going to do my work. Like I just tapped, I could just re-tap on it if you want me to. I'm going to make a copy and we are going to do the notes together. You guys can do the same thing. So if you want to hit File, make a copy, you will need to use this for the worksheet that will be due at the end of class. So I would make sure to type your notes on this sheet. So the first thing we're going to talk about are solids, liquids, and gases. And we kind of went over this at the beginning of the year, but a solid will be a type of matter that has molecules very packed together, little to no movement. So in the solid phase, you can say that the molecules will take the shape of that solid and they are very packed together, tightly packed, and they don't move. A liquid, molecules will take the shape to the container the liquid is placed in. And then another review, gas, really the molecules are moving freely. So something we did at the beginning of the year was draw a picture of each of these things. And we will do that in the next part, going from solid to liquid to gas. I will show you in a picture of how these things will look. But we're kind of more focused on today how a substance can change states from a solid, liquid, and or to a gas. So a substance can change states when the temperature or pressure of a system is altered. So just like if you put a thing of ice out and it starts to melt, you are changing that temperature. Therefore, it is changing its state from a solid to a liquid. Same thing when you boil water, you see all the steam come out. That is changing from a liquid to a gas. So When temperature or pressure increases, molecules interact more with each other. And this makes sense because when you raise the temperature of water that is boiling in a pot, it starts to turn to water vapor or steam, and it goes from a liquid where they are freely flowing on the container to where they are in the air flowing anywhere they want to be. So when pressure increases or temperature decreases, it's easier for atoms and molecules to settle into a more rigid structure. That makes sense when you freeze water in an ice cube tray. It makes its own shape and it will stay in that shape as a solid. As a liquid, it just flows in the container, but once you put it in the freezer, it will settle into its rigid structure of a solid. So when pressure is released, it's easier for particles to move away from each other. That kind of goes hand in hand with the temperature increasing or decreasing. So certain phase changes that you will need to know are melting, freezing, evaporation, condensation, and then there are two that you might have not heard of, or you might have from biology, I don't know, or in space science or life science, whatever you took in middle school. So deposition and sublimation are the other two that you may not know of that you might just learn today. So melting is when a solid turns into a liquid. That's pretty self-explanatory. You know, when things melt, they start at a solid and they will go to a liquid. Just like if you have ice cream at home, you leave it sit out for a while, or in the sun, it will go into a liquid. Freezing, that's when a liquid turns into a solid. And that's also, you see that sometimes in everyday life. I know when I make a drink in the morning, iced coffee, I have to refill the ice every day. So I have to literally put the water in and make the ice cubes in a tray. So I'm freezing something every morning before I go to the school or while I'm home teaching you guys. So evaporation is when a liquid turns into a gas, and condensation is when a gas turns into a liquid. You could see the condensation on a glass. If you leave it out, you can see that all the condensation on a bottle, that's what people think, or a cup when you are drinking like water or a pop outside. So deposition and sublimation are some things that you might not have heard of in your previous science classes. Deposition is when a gas turns into a solid without passing through the liquid phase. So it'll go straight from a gas into a solid without going through the liquid phase. It'll automatically turn, and that is due to a quick change of temperature or pressure. Sublimation is the same thing except opposite. So it is when a solid turns into a gas without passing through the liquid phase. So finishing up this definition, sublimation is when a solid turns into a gas without passing through the liquid phase. So now that we have talked about all different types of phase changes, we are going to talk about where they would be placed on a phase change diagram. This is just an overall way to learn phase change diagrams. This isn't on a specific substance, or else there would be certain temperatures along the y-axis. If you look at the y and x-axis, they are pointing up and to the right. That means the temperature is on the y-axis increasing, and the heat energy is on the x-axis increasing also. So as you take a look from the left of this diagram and move to the right, all of the temperature and heat energy is increasing. So I have listed A through E. I'm going to write them as notes on this screen. It just looks very similar, but I had to make it look less fuzzy because the picture was kind of fuzzy. So I just drew it myself. We're going to go over what each of these things mean. So A shows a picture of molecules that are tightly packed. So that will be the start of a phase change diagram, and that phase is going to be a solid. And then if we go along through the different types of matter, C now shows a picture of molecules that are forming to a container. That will be a liquid. And then E shows a container filled with molecules that are moving freely. That will be a gas. So overall, I'm going to draw an arrow going up. That means we are heating something. So temperature is increasing. As you can see through that y-axis, that means we're heating something. If you were to look and start at the right side of this diagram and go to the left, you would be cooling something. And that makes sense because going from a gas to a liquid to, say, a solid, you would be going from a liquid to a solid, you would be freezing something. So that makes sense that you are getting colder and going towards the lower temperature. So if you take a look at B, going from either a solid to a liquid or a liquid to a solid, so those would be the B arrows, freezing and melting. Going from a liquid to a gas, going from straight to a liquid to a gas would be evaporation. And going from a gas to a liquid would be condensation. We just went over those definitions. I'll make that a little bit more clear. Condensation. Condensation. So going from A to E and E to A, that would be deposition and sublimation. I'm not going to make you write that on this diagram. But this describes, so now that we have looked at a phase diagram, a phase change diagram of just a regular substance, I thought we would look at a phase change diagram of a certain substance that we deal with a lot. So we are now going to look, and if you go back to your notes, right underneath, all the A through E is a phase change diagram of water. And this is what I was talking about, where it gives a specific temperature. So when you start at the solid state of water, it is very cold. It is below freezing, which is 0 degrees Celsius, and it takes the shape of a solid. It is ice. Then you could leave ice out in your house, or you can leave it outside. It starts to get warmer. And after it reaches above a temperature of 0 degrees Celsius, it will start to melt, and then it will change into a liquid. So once you get past 0 degrees Celsius, which is 32 degrees Fahrenheit, that makes sense because your houses are usually hotter than 32 degrees Celsius. It will melt if you would leave ice out in your house. So it then turns into a liquid. So if you would put that same ice you melted into a liquid onto a stove, it would then reach a temperature, because you're putting on the stove, you're adding heat to it. If it gets to a point where it's 100 degrees Celsius, it will start to boil and steam will start to evaporate out of the pot that you're boiling it in. So it goes from a solid to a liquid to a gas. And it shows this phase change diagram is also nice. Usually they don't show what the molecules look like on top, but it's nice that it does that because you can see how they are changing. So it's going from a very solid, structured solid as ice, and then you can see it's starting to lose its order and it's going to fill the shape of the container. And then you can see also, as temperature is still rising, it is then going to turn, or you see in this box, it is starting to move more freely, and that is because it is turning into a gas, which the molecules move very freely. So this is nice because it shows you directly right where the lines are. This is where melting will start to happen, and this is where evaporation will start to happen. And if you were to look from right to left, this is where condensation would start to happen at 100 degrees Celsius, and this is where freezing would start to happen. If you are at 0 degrees or go below, your solid or your liquid ice or liquid water would turn to ice. And you can do this at home if you want to today and try to see if you leave ice out when it will start melting. Or you could even then change that ice, put it on the stove, and see what temperature it starts to boil. It should be 100 degrees Celsius. And your house is hotter than 32 degrees Fahrenheit or 0 degrees Celsius. So it will melt if you put it outside. So that's something we could have done in class if we were together, but you can also do at home and do a little science experiment. We are now going to work on a worksheet on the stuff you just learned. So if you go to Classroom, there should be a Google form that you will fill out that'll just ask you to kind of answer some questions that are on phase changes and phase change diagrams. So if you watch this, you should be good. So if you have any questions, email me. If not, I will see you next class where we will start chemical reactions, which is on chemical changes, not these types of physical changes.